masalah kalau dia nggak turun. Kalau karet terlalu
It's so noisy. Hey everyone, welcome back to my channel. Today we will be sour and salty because we will be talking about salt. In this topic, we will differentiate salt based on its solubility in our most common solvent in chemistry, which is water. So we're going to classify it into two different kinds of salt. The first one is the soluble salt, and as the name suggests, means that this salt can dissolve well in water. The second kind of salt is the insoluble one. Insoluble salt means that it has a very low solubility in water, but to make it simpler for your level, we are just going to assume that it doesn't dissolve well in water. Okay, so the one that dissolves well and the other one does not dissolve well. For the soluble salt, there are two ways to make the salt. The first one is by reacting aqueous acid with aqueous alkali. Now alkali is actually a base, but it is soluble, means that this base is an aqueous solution. So we're going to mix aqueous solution and aqueous solution. At the end, we're going to get salt. This salt can be separated from the product mixture by evaporating it later. The other way to make soluble salt is by reacting the aqueous acid with the insoluble base. Okay? Now there are three types of insoluble base that we can use. The first one is just a plain metal. In this case, we're going to use magnesium. The second one is by reacting it with an oxide. So it's a metal oxide, which is a base also. In this case, we are going to use copper oxide. And the third one is by reacting the aqueous acid with a metal carbonate. In this case, we are going to use calcium carbonate. I think the simplest way to make soluble salt is by reacting acid with an alkali. We do it so often, and I will put the link to my previous video in the description box so you can easily see it. In that video, I react acid with an alkali and then I evaporate the product mixture after with a Bunsen burner, and at the end we can isolate the crystal of sodium chloride. Okay, the other way to make soluble salt is by reacting acid with insoluble base. The first method that we're going to use is reacting hydrochloric acid with magnesium, which is a base because it's a metal. Now, I'm going to show you a piece of my magnesium ribbon so that you can make your observation. Now, you might want to remember that in chemistry, your observation skill is very important. Seeing or to see is different from to observe. Okay, when you observe, you're going to take notes on if you see any color change happening during a reaction, or maybe there is a temperature change. Sometimes maybe you can smell something pungent coming out from that, or any fizzing or effervescence or gas bubbles. This is a piece of metal which is magnesium. I'm going to make it closer to the camera so you can see. Okay, you can see that instead of being gray and shiny, just like the usual property of metal, it is covered in grayish or dark material. We need to scrap that dark or grayish substance because it will hinder the reaction from happening. Okay, it's quite unreactive, so we want to make sure that it's cleaned before we react it with our acid. In the video down below, you can observe a few things when you react hydrochloric acid with magnesium. The first observation that you can make is that fizzing or effervescence or gas is formed there. You can see it as it forms bubble on the surface of the magnesium. I only use low concentration of hydrochloric acid here, so this reaction is not that fast. The second one is that the size of magnesium decreases throughout the reaction, because some of the magnesium has dissolved into the acid. The product of this reaction should be a clear solution. But you know from the reaction here that actually magnesium chloride salt being produced. But since magnesium chloride is soluble inside water, we cannot see the crystal because it's mixed already inside the solution. So we are going to isolate the salt by evaporating the mixture until most of the water has gone and we can isolate the magnesium chloride. Now move on to the other method of making soluble salt, which is reacting acid, aqueous acid, with an oxide of a metal or metal oxide. Here I am using copper oxide. You can see the appearance of the copper oxide. It is a black powder. And we are going to carefully mix it with our sulfuric acid. And you should see that as more copper oxide is being put into the solution changes color from clear to light blue. Now it is important to note that we always want to have excess of the base, because at the end, if we want to evaporate the crystal of the salt produced, we don't want to evaporate the acid into the air, because acid is corrosive to our lungs, so we need to be careful. How we make sure that we have put excess base is by looking at the mixture. You will continuously add the base and keep on stirring the solution until the base is no longer dissolving into the solution. Okay, now you can see that there is a color change again. Initially we have a light blue solution. At the end we're going to have quite darker color of blue, and you can see that there is no more copper oxide dissolved into the solution. It is left behind at the bottom of the beaker, and that is when we can begin to filter the excess of copper oxide using a filter paper and the funnel, and we will obtain the clear blue solution. Then we can transfer that clear blue solution into an evaporating dish, put it on top of a Bunsen burner, and then we're going to evaporate most of the water. Now, it is important also to note that whenever we evaporate salt to isolate it, we don't want to evaporate it until complete dryness, because some of the salt can decompose in high temperature. So we just want most of the salt to evaporate into the air, and then we're going to just air dry the salt. Okay? The last method of making soluble salt is by reacting aqueous acid with a metal carbonate. Here I'm going to use calcium carbonate to do it. Now, based on the reaction, you can see that carbon dioxide is being produced in the reaction, which means that it will be produced in the form of bubbles of gas, and you should be able to see it from the observation. The salt that we produce in this reaction is calcium chloride, which then can be isolated using evaporation. Now we move on to the other type of salt, which is the insoluble one. Insoluble salt can be made by reacting an aqueous salt solution with another aqueous salt solution to make a precipitation out of it. The reaction itself can be called precipitation. As you can see from the video down below, I react potassium iodide with lead nitrate. When I mix them together, you can see that a precipitation, or for exact, a yellow precipitation is formed. That is actually a lead iodide. There are two salts being formed in this reaction. The first one is potassium nitrate, which is soluble, so the aqueous solution accompanying that yellow powder is actually potassium nitrate, and the yellow powder or the yellow precipitate that you see in the mixture is actually lead iodide. Now obviously, since we have two different phases here, you know what is the best method to separate the lead iodide. We can use filtration to do it. You can always refer to the salt solubility table to see whether a specific type of salt dissolves in water or not, and from there you can deduce the best method to make it. Now it's time for comprehension. Okay, that's the end of our discussion today. I hope you learned something from it, and see you around. From the video down below, you can observe a few things when you